Hey everybody, so this week we're going to look at multiplying matrices. Multiplying matrices is a process that is a little more complicated than adding and subtracting matrices are, because it's more than just going straight across and adding or subtracting what's in the same locations. It's a whole algorithm that we have to kind of learn and practice. And I'm just going to show you an example real quick of what to do if I'm multiplying a 2 by 2 matrix times a 2 by 2 matrix, and show you what the algorithm is. So let's say I've got a matrix here, and I multiply that times another 2 by 2 matrix, like that. And again, it's not just A times E, B times F, C times G, D times H. You don't do that. There is a process involved. Now, the first thing we need to know about multiplying matrices is that you have to write out the dimensions of the matrix. Okay? So, for example, the first matrix is a 2 by 2. The second matrix is a 2 by 2. And in order for this matrix to actually even be able to be multiplied, these middle numbers have to be the same. Okay? If those two numbers are the same, then the multiplication can happen. The matrix does exist. If those numbers are not the same, you cannot multiply these together. Okay? So that's the first part. The second part, these numbers on the outside, this is the size of the new matrix. Okay? So if I'm taking a 2 by 2 times a 2 by 2, that's pretty simple. The middle numbers are the same, so that can be done. And so since it can be done, then the numbers on the outside is 2 by 2 as well. And so my new matrix will be a 2 by 2 matrix. And so what I do is I put some blank spaces over here, because I'm going to have to do some writing in these places. I'm going to zoom in so that I can see what I'm doing. And what we look at when we're multiplying matrices is the rows and the columns. Okay? And the first row, or sorry, in the first matrix, it's all about the rows. We have rows. And in the second matrix, it's the columns. All right? And so what we look at here on our resulting matrix and our answer, this location up here in the top, up here, this is the first row and first column. And so what I look at my first row and first column of the two matrices. The first row on the first matrix is A and B. So I have an A and a B. And then the first column is EG. EG. And then I add them together. And so the first element of the matrix of a 2 by 2 is AE, A times E, plus B times G. And then I look over here to this spot. This is the first row, second column. The first row, again, is A, B. The second column of the second matrix is F, H. And so this is found by finding AF plus BH. Down here, this element right here. This is the second row, first column. So the second row is CD, and first column is EG. And then the last element over here, first row or second row and second column. So it's CD, and the second column is FH. And so my resulting matrix is this up here. See what I mean? It is not as simple as just multiplying across. Okay? And again, it's a whole process that we have to practice, and this is something that will take a little while, and so you need to make sure you're practicing this. Let me work an example with you now. Let's just take 2 by 2 times a 2 by 2, just like we were talking about. And so it's a 2 by 2 and a 2 by 2. These numbers are the same, and so my resulting matrix is going to be a 2 by 2. So I draw in my spaces for a 2 by 2 matrix. All right, so again, we're looking at rows by columns. Rows, columns. So this first element, first row, first column. So for the first row is a 4 and a 6. First column is a 0 and a 6. So the first element is found by taking 4 times 0 plus 6 times 6. Next, we have first row, second column. First row is 4, 6. First column is 0, or sorry, second column, not first column. Second column is 1, negative 3. Next, we have second row, first column. That's down here. Second row, first column. Second row is negative 6 and 8. First column is 0 and 6. Add those together. Next, we have second row, second column. Second row is negative 6 and 8. Second column is 1 and negative 3. And now we do the math. The first element is 4 times 0 plus 6 times 6. Well, 4 times 0 is 0, and 6 times 6 is 36. The second element is 4 times 1 plus 6 times negative 3. So that's 6 times negative 3 is negative 18, plus 4 is negative 14. The second, or the third element, second row, first column, is negative 6 times 0 plus 8 times 6. Well, negative 6 times 0 is 0, and then 8 times 6 is 48. And then the last element is negative 6 times 1 plus 8 times negative 3. Negative 6 times 1 is negative 24. And 8 times negative 3, sorry, negative 6 times 1 is negative 6. And negative 3 times 8 is negative 24. So negative 6 and negative 24 is negative 30. And here is our final answer. Okay, again, it is a whole process. This isn't something that you can just do by just multiplying straight across. All right, let me do another example. This time I'm going to change the size of the matrices on us here a little bit. Okay, instead of just a 2 by 2 and a 2 by 2, this first matrix is a 2 by 3, 2 rows, 3 columns. The second matrix is 3 rows, 2 columns. So it's a 2 by 3 times a 3 by 2. And so my resulting matrix, so first off, the middle numbers are the same, so I can multiply them. And so my resulting matrix is going to be 2 by 2. have 1, 2, 3, 4 elements to it. And I'm going to make this a little bit neater for us because it's going to get a little messy as we're trying to do these. All right. So this first element is going to be the first row, first column. We have our rows, we have our columns. First row, first column. First row is a 3, a -1, and a 2. First column is 2, 7, 0. And then we add all those together. So it has 3 things we're adding together there. Okay? Next. Next element is going to be the first row, second column. First row is 3, -1, 2. Second column is 5, -2, -3. And then we're adding those together. Next, second row, first column. The second row is 7, 4, 8. First column is 2, 7, 0. And then we add those together. And then the last one, second row, second column. Second row is 7, 4, 8. Second column is 5, -2, -3. And now we clean this up a little bit. 3 times 2 plus -1 times 7 plus 2 times 0. And you can grab a calculator for that if you want, or if you can do it mentally, that's fine. So 3 times 2 is 6, plus -7 is -1, and that's 0, so -1 is what's going to go here. The next one is 3 times 5 plus -1 times -2 plus 2 times -3, that is 11. And the next element is 7 times 2 plus 4 times 7 plus 8 times 0, which is 42. And I'm just using a calculator here to go through this a little quicker. And then I've got 7 times 5 plus 4 times -2 plus 8 times -3, and that is 3. And so my resulting matrix is this 2 by 2 matrix. Okay? Again, it's not as simple as just multiplying across. In fact, with different size matrices, you can't just multiply across, can you? It wouldn't work. So you have to use this process. It's a long process. It takes some time. You've got to just work through it. Last, I've got this example. My first matrix is 2 rows, 3 columns. This matrix is 2 rows, 3 columns. In the middle, those numbers are not the same. Therefore, the matrix does not exist. or DNE. It does not exist. You cannot multiply matrices where the middle term is not the same. Okay? If that happens, you can stop. Just say it does not exist. It does not work. You cannot do it. So I just wanted to show you an example of something like that that does not work. Okay, so if you have questions, feel free to join me on Zoom. You can always also YouTube other videos of multiplying matrices. I've got some other little tricks I can show you on Zoom that if you have questions on how to do these, I'm happy to do that. So I will hopefully see some of you guys during the week. If not, guys, have a great week. Stay home, stay safe, stay healthy.